That is SprayBot invention. That is SprayBot invention. And you can see that there's a whole lot of electronics inside there. All the electronics. It's just, you know, the electronics of today are just, well, you know, it's enough to do your head in, really, the electronics of today. I built this, you know, well, you know, it's supposed to be a LiDAR unit, you know, for picking, sending out a signal and then receiving the signal back, you know, LiDAR is laser radar. And now, appears as though it's not required. Everything is all going to be visual, so the whole thing of how cars drive themselves using immensely powerful computers that can do artificial intelligence and all of that. They train themselves like human brain, and because of that elevated amount of intelligence now that AI is offering, we can just do it all visual, just all visual. So that's a Canon camera lens there, and I've got maybe two other infrared or maybe microwave for doing the tracking the path down the row of cotton, comparing it to the basically simulating what is it that the human agricultural pilot does, one of the most skillful jobs in the world. Well, it's a skillful job to fly an aeroplane in the first place, but to fly an aeroplane so close to the ground at such speed with such accuracy so that you can do crop spraying, it's unbelievable. But we think we can actually get a machine to do that now, and to take the human out of the cockpit. Now, ag pilots don't want to be taken out of the cockpit. They love their work. They do. So when they see this, they feel a cold shiver of change. They do. You're going to take my job away from me, are you, Ian? But the reality of it is 1% of ag pilots kill themselves every year, or put themselves in a wheelchair, or seriously maim themselves. 1%. It's almost getting on. There's only one form of aviation that was more dangerous than that, and that was the we're celebrating the 80th year of that now. 80 years since the Battle of Britain, and the 400, let's call it 500 or so pilots that lost their lives on the British side, and the more than 1,000 pilots that lost their lives on the German side. And the loss of nearly 1,000 Allied aircraft, Spitfires, Hurricane, and the loss of well over 1,000. That's the only death rate that's higher than the crop spraying. Really, it is. So anyway, the platform and how it's done, I'm not an electronics engineer. I'm not. The platform is irrelevant, really. What I'm about is what do we use as the sprayer? Well, I'm arguing that we use an electrically driven spinning disc unit, which gets the spectrum of the spray droplets you are producing. So it's a gravity feed, don't need to waste precious payload. Hang on, I'll just switch the fan off. I've got a fan here now. These fans, wonderful. You can, you know, keep yourself cool with the fan. You don't need air conditioning. Okay, that's a separate issue. But this is, you see, this is the electrically driven spinning disc, and I'll just take the cap off. There we go, and it's electrically driven. This comes down on an arm, so I won't do that at the moment. But it does extend down, and it extends down a foot or so, maybe 2 or 3 feet into the. So you can get this nozzle head into the canopy, the what's called the crop canopy of the cotton. Cotton's tall; it's over 1 metre tall, maybe, as you wander through it down the rows. you get the nozzle actually in between two rows of cotton. So it's marvellous. You're getting the spray release height to nil, negative, if you're saying the near the top of the crop canopy is like height 0. So that's getting spray drift right down, but you're getting all the droplets between 100 and 300 microns. So we're saying that any droplet that's less than 100 microns in size is driftable. It's going to drift and contaminate cattle, the stock feeding route of cattle, the pasture, the dry yellow grass collects the spray drift from the adjacent cotton farms. So we're going to get rid of that. There's not going to be any spray drift because we're getting rid of all the droplets. It's controlled droplet application, you see. So it rotates a thin film, and the film forms ligaments, and the ligaments break up into uniform sized droplets depending upon the speed and the flow rate. It's all well understood. By the way, the company Micron, they've gone. Sadly, they've quit. Wonderful association Cranfield and Imperial College have had with a wonderful company that led there by Edward Balse and then his son Tom, John Clayton people. Anyway, this is a Micron spinning disc we have here. This is my mission, is to try, if you're gonna do high-tech crop spraying, right? Because we've got to feed 10 billion people by the year 2050. This is the mission. It's all about food security. How are we going to do this? Well, we've got to grow food in Africa where there's good soil and water. Boy, there's pests and bugs in Africa like you wouldn't believe. Yeah, we can't do it all. We can't really feed 10 billion people organically. It's got to be some highly modern, environmentally non-damaging, human health non-damaging pesticides used a little bit and very efficiently using high tech. So, you know, drones, they could be helicoptery, you know, you know, quadcopters and hexacopters, even octocopters. You know, there could be those, probably will be. The platform doesn't concern me, but what does concern me is the device that we use, the device that's used for the spraying. It shouldn't be a hydraulic nozzle. If you're using a hydraulic nozzle, you've got to pressurize up to at least 2 or 3 bar. That's a weight, the pump system, pressurized plumbing. It's weight, waste. So it's gravity feed to electrically spinning disc. We can control that droplet size to 250 microns. So we're going to call this the SPIN250. Very few droplets less than 100 microns that will drift. Very few droplets above 300 microns that are wasteful and just fall to the ground as pollution. Okay, so this is the idea. Received a patent. We filed a patent on it in 2003. 17 years later now, year 2020, we're going to have a go at this, doing this. Okay, so this is the University of Queensland, Gatton, led by Professor Andrew Hewitt. Myself, I'm Ian Craig, and we are going to be ably assisted in the aviation department and technical matters by Bruce Llewellyn. So we formed a team of 3, and Chris also, and 1 or 2 others probably. We'll be forming a team to have one last crack at getting this done. Okay, so tech is the way. Tech is, you know, tech is the future. This is what we should be doing. You know, this is tech. You know, pesticide application to keep humans alive is the mission. This is what we should be doing. You know, this is our belief in the way we should be going about this. And the future is technology.